Hello everyone and welcome to today's webinar, How to Break the VNA Entry Barrier, Building a VNA in Multiple Stages, brought to you by HIMSS and GNAX Health. My name is Patrick and I'll serve as your moderator today. Before we get started, I'd like to give you a few instructions regarding the Q&A process that will happen at the end of today's presentation. Please be sure that you've submitted all of your questions in the Q&A panel, as questions submitted in the chat area may be missed. And just a reminder, you may submit your questions at any point during today's webinar. For technical assistance during today's presentation, send me a private message by selecting Host in your chat area. If you're having trouble with audio today, please let me know immediately to assist you with your options. And finally, a full archive of this presentation will be available at a later date, along with a PDF version of the presentation. There will also be an exit survey at the end of today's webinar, and we appreciate any feedback that you have. And now I'd like to introduce today's presenters. We'll get started. You're hearing from Michael Gray. Mr. Gray is a consultant specializing in the digital management and distribution of medical image data. Mr. Gray's area of expertise are market analysis, technology analysis, strategic planning, equipment utilization, needs assessment, workflow analysis, and vendor analysis and selection. Mr. Gray's unique perspective has proven invaluable to radiology, cardiology, and information system administrators planning the introduction of new image management technologies into their imaging departments and hospitals. Mr. Gray routinely speaks to both national and local healthcare organizations on subjects such as technology, business case modeling, and system deployment strategies. We'll also be hearing from Mariano Maluf. He's the Chief Technology Officer for GNAX Health, where he establishes the company's technology direction within the cloud computing market space, ensuring alignment and delivery of innovative cloud computing products and services. With over 20 years of experience managing multi-platform mission-critical systems, Mariano has held technical, operational, and leadership positions at several Fortune 500 companies. Additionally, Mariano is a VMware vExpert and president of the worldwide VMware user group. And with that, I'd like to pass things over to Michael Gray, who will begin today's presentation.
Well, thank you for that introduction, and welcome, everyone. Today we're going to look at a few vendor-neutral archive deployment strategies that will probably remind you of those first-generation radiology PACS deployments. We're going to see how you can break the VNA entry barrier by building a VNA in multiple stages. Here are the objectives of today's presentation. I'll start by providing some background on vendor-neutral archive. What is it? What does it look like? What problems is it supposed to solve? How big is it, and how much does it cost? Then we'll review some radiology PACS history that will provide something of a blueprint. And we'll look at some current problems that many organizations are facing today. I'll introduce what I call VNA precursor products. And we'll look at a few entry-level VNA deployment strategies. Then we'll look at how to build out those entry-level products to full-blown VNA configurations. The presentation wouldn't be complete without looking at the economics, so we'll look at some numbers. I also thought it would be useful to review some of the frequently asked questions related to VNA. At the end, I'll provide some conclusions, and then I'll end up with an introduction to GNAX and its technology and service offerings. What exactly is the definition of a vendor-neutral archive? Well, I think the term itself is somewhat misleading. After all, a vendor is obviously involved. I always thought that the better term was PACS-neutral archive, but I guess that term made too much sense, so it didn't stick. So I'm going to read this definition on this slide verbatim. Vendor-neutral archive is an enterprise-class data management system that consolidates primarily medical image data from multiple imaging departments into a master directory and associated consolidated storage solution, thus replacing the individual archives associated with departmental PACS, systems with unfortunate proprietary characteristics that limit their interoperability. By virtue of it consolidating all of the enterprise image data, VNA is also a unified image data repository for the electronic medical record system. So the graphic on this slide emphasizes the fact that a properly configured VNA is almost always configured as a mirrored set of subsystems. There are two instances of each application, one in each of two geographically separate data centers. Two separate VNA storage subsystems support disaster recovery. Notice that I'm also including an instance of a universal viewer in each of the data centers. The univiewer, as I call it, image enables the EMR and provides a business continuity solution. Very few department PACs can provide such a robust DR-VC solution. I came across an interesting article in Health Imaging and IT published last July. In it, the author lists the top 10 problems with PAC systems. Not surprisingly, the VNA addresses 7 of those top 10 problems. Number 1, the VNA enables image sharing between department PACs in the same organization, as well as between department PACs in different organizations. Number 2, the VNA can provide a true business continuity solution that a PACs cannot provide. Number 3, the VNA can dynamically modify DICOM headers in such a way as to guarantee that images from disparate PACs will be compatible with any PACs hanging protocol. Number 4, the VNA will consolidate and standardize the servers and storage solutions required to manage all of the enterprise image data for its life cycle. Number 7, the VNA will significantly reduce the complexity and cost of future DICOM data migrations, as only a small fraction of the historical data needs to be migrated to a replacement PACs. Number 8, the VNA takes responsibility for long-term management of the image data, as well as image enabling the EMR. Removing these responsibilities from the PACs makes the PAC solely responsible for supporting operations confined to the imaging department. The choice of PACs that best meets those requirements can be shifted back to the imaging department. Number 10, as I've already said, the VNA provides for a very robust disaster recovery solution. The only workable solution, in my opinion, to solving most PACs problems is to deploy a vendor-neutral archive. We need to take the A out of the PACs, it's been often said. Give the organization an enterprise-class DR and VC solution. The VNA can also accept non-DICOM image data, thus broadening the scope of the patient's longitudinal medical record. The VNA incorporates the tools to dynamically translate between disparate PACs, referred to in the requirements as bidirectional dynamic tag morphing. The VNA brings sophisticated information lifecycle management tools to the organization, and that includes a valuable purge mechanism that will be driven by the organization's retention policy. As mentioned, VNA effectively eliminates those massive DICOM data migrations required every time you replace a department PACs. VNA applications are typically hardware agnostic, opening up a much wider choice of storage solutions. And the VNA is a much easier way to consolidate image data storage, and possibly the only way to guarantee data exchange between disparate PACs. VNA shifts control of the image data from the PACs vendor to the organization, which gives the organization all of the leverage in the next PACs negotiation. Univiewer VNA combination is a more sensible approach to image enabling the EMR. So we see that the properly configured VNA is a big system, which begs the question, how expensive is it? Well, it's obviously going to be more expensive than your biggest departmental PACs, since it will be managing all the data from all of your PACs. There could be a factor of 2 in the equation, because the proper architecture is a mirrored, dual-sided configuration. The point I want to make here is that the properly configured VNA is big enough and expensive enough to require multiple years and multiple budgets. And this is very reminiscent of those first-generation PACs deployments. I think we were going to insert a poll question here. I'll give you a second to think about the answers, and then I'm going to continue. All right, so let's take a brief look at the early days of radiology PACS. Even as late as the mid-90s, those first-generation radiology PACS required large investments. And there was admittedly some doubt as to whether that generation of PACS would successfully replace film. So maybe that's another reason why we didn't deploy things all at once. As a consequence, early PACS deployment strategies focused on solving more manageable, smaller problems with entry-level products that were moderately priced. The mini-PACS for CT, for MR, and ultrasound, and teleradiology systems were considered precursor products that could ultimately be stitched together to create the full-blown departmental PACS. The typical PACS deployments in the mid-90s were phased over several years and several budgets. As Yogi Berra said, it's deja vu all over again. So let's look at some of the more manageable problems that many organizations face today. With storage refresh cycles being 3 to 4 years, there are recurring PACS media replacement projects. And each of those will require the cost of a media-to-media data migration effort. There's the painful PACS replacement that requires that onerous, complete DICOM migration. There's the need for image sharing between PACS and image sharing with outside physicians that hopefully could be conducted over the Internet as opposed to a dedicated network. After the deployment of an EMR, there's the need to image-enable the EMR. Doing second copy of the data on removable media stored on a shelf is technically HIPAA conformant, but the real DR solution requires a reliable backup system in a geographically dispersed data center. Since very few, if any, PACS can be configured to provide a real business continuity solution, what happens when the PACS is down? How do you access and view your priors? In the same vein as those mini PACS of yesteryear, here are a few examples of VNA precursor products. Media replacement. Arm wrestle your PACS vendor into letting you replace the old media that they sold to you with a current generation open storage solution that you can share with other department PACS in a future VNA. Data migration engines. Replace an old, ineffective DR solution with a VNA-fronted open storage solution. Migrate the proprietary DR copy through this VNA and create a normalized copy of the data. This entity is then both a DR solution to that PACS, but it's also a data repository compatible with the next PACS. Migrate the DR copy to a VNA-funded cloud infrastructure. DICOM routers. These simple and inexpensive appliances facilitate PACS-to-PACS image sharing. They're capable of automated, rule-based routing. For example, all neurology studies to a different off-site PACS for Nighthawk interpretations. And they're capable of that automated tag mapping that guarantees data compatibility. Here's an example of apparently putting the horse before the cart, the univiewer. The ideal univiewer is a zero or near zero server-side rendering display application that even when deployed as a standalone, without a VNA, can image-enable the EMR. Most univiewer applications can aggregate a patient's image data across multiple PACS. The univiewer can also provide both inside and outside physicians with secure Internet access to the image data spread across multiple PACS systems. When the univiewer is combined with a geographically dispersed DR solution, the result is a true business continuity solution when any of the PACS go out of service. Here are a few entry-level strategies that are designed to solve a specific or a group of related problems. Each successive level that I'm going to show you adds one more layer of complexity and potential, And each level has an upgrade path to a full VNA. So I refer to level 0 as the data sharing and interoperability level. This involves deploying one or more DICOM routers to facilitate PAX-to-PAX data exchange. These routers incorporate VNA technology, so they support rules-based auto-routing, and they use bidirectional tag marking to guarantee data compatibility at the recipient PAX. The rationale? This is a much more efficient and an effective way to transfer data between PACs than the often hit-and-miss approach based on exchanging CD-DVD copies. I refer to level 1 as the data storage level. And level 1A, a current generation open storage solution, is deployed on site. And the primary or first copy of the data is migrated to this storage as the older PAX media is retired. An option worth exploring is keeping the most recent 3 years of the primary copy on site and transferring the balance to a cloud infrastructure. Of course, you choose the appropriate storage solution to meet the performance requirements of that PAX. Rationale? This upgrades the price-performance ratio of the on-site storage. Choosing an open storage solution protects the organization against obsolescence. Transferring older data less likely to be relevant and therefore less likely to be accessed to the cloud, reduces the overall cost associated with storing that data. Level 1B offers something of a twist. Here, you transfer the entire set of the second copy of the data, that DR copy, to the cloud. There is no requirement for or involvement of a VNA technology here, so the data is still in the proprietary format of the departmental PAX. This is the true, geographically dispersed, HIPAA-conformant DR solution that does not require the organization to build or lease and manage the infrastructure of that second data center. Rationale? This strategy secures data integrity and reduces both capital costs and operational expenses associated with on-site DR solutions. My level 2 provides the more sophisticated and the more valuable vendor-neutral data management. This strategy calls for deploying a VNA-based migration engine on site. The organization then begins a proactive DICOM migration of all of its PAX data to a VNA-fronted cloud infrastructure. When this migration is completed, you retire the PAX-driven DR solution. The VNA tag marking creates a neutral DR solution. The cost per study fee covers the data migration and the managed storage costs. The result is a HIPAA-conformant, geographically dispersed DR solution that is managing a neutral copy of the data. Rationale? This strategy transfers control of your data from the PAX vendor to the organization. The existence of a neutral copy eliminates future DICOM migrations. This move reduces capital costs and operational costs associated with the DR solution. This move also returns the choice of the next PAX to the imaging department. The next logical step up in both complexity and functionality is viewer enabling this cloud-based second copy of your data. I refer to level 3 as neutral data management and distribution, because the placement of the UniViewer application in the cloud in close proximity to the second copy of the data will allow the organization to efficiently distribute this second copy of the data to the physicians. The UniViewer is activated once, let's say, 6 months of new and most recent data has been migrated to the cloud. In this strategy, you are image enabling the EMR with the cloud-based second copy of the data. The UniViewer must be chosen carefully, though. The strategy requires that zero or near zero client and server-side rendering application in order for the performance expectations to be met. you should expect roughly 3-second delivery of the first screen content, even though the data is being delivered from the cloud. Stay away. Rationale? The strategy reduces capital costs and operational expenses associated with a business continuity solution, image enabling the EMR, and internet image sharing. It should have occurred to you that Level 3 is not a full-blown VNA by any stretch. It's not half of one. But it solves a number of key pain points. So what exactly is required to upgrade from Level 3 to a full VNA? Well, first, you deploy the primary instance of the VNA on-premise in your primary data center. Second step, have the cloud vendor perform a media migration of your secondary copy of the data to a storage solution that you ship to their data center. Third step, cloud vendor then ships the populated storage solution back to your data center, and then this becomes your primary on-premise storage solution. Step 4, establish the local PACS and the EMR and the HL7 interfaces to your on-premise instance of the VNA. Step 5, you upgrade the DR and the BC level VNA licenses to full functionality. Last step, you reduce the local PAC storage to maybe 12-18 months as you retire the older media. Well, this is a graphic, and it doesn't have the cute builds that I built into it, so bear with me as I explain to you what looks on the slide here to be the end state. This is a graphical representation of a Level 3 configuration that has been upgraded to a full VNA. The VNA and the univer applications are in the cloud. They're sitting in front of a storage solution that contains that entire second copy of the organization's image data. Early in the deployment, the entire primary copy of the image data is still being managed by each PACS. And the local gateway server, which disappears from this graphic, would still be there as the link between the PACS and the cloud. As soon as the primary VNA subsystem is established in the organization's data center, the gateway server is no longer needed, so it's gone, like in this illustration. And then lastly, eventually the PACS local image cache can be reduced to 18 to 24 months, which is the little skinny disk that you see in the picture. So we went from the stage 2, or to the level 3, all the way up to a full-blown configuration. Now the exciting part. Let's take a look at some of the economics. First of all, let's look at one example of a Level 1A strategy. These are the assumptions I've listed. Let's assume that the long-term storage solution provided by the PACS vendor is at least 3 years old, 3+ years old, and the maintenance costs are rising, so you're thinking, well, I think it's in need of replacement. So let's look at the 5-year total cost of ownership of replacing it with a high-end storage solution on-site and managing it yourself. And then we're going to compare that to a strategy of keeping the most recent 24 months on-site and migrating all of the data to a cloud storage infrastructure for long-term management. We're going to look at a profile for a single hospital running roughly 200,000 annual procedures and about 820,000 procedures historical data. I've summarized the storage calculations here. You remember you're going to have access to this slide deck after the presentation, so you can take a closer look then. You can see how we've arrived at some of the required terabytes. The projected 5-year total cost of ownership for this strategy, you look down the bottom of the page, is $1.6 million. Well, we're not going to share GNAX pricing in this presentation. The GNAX is prepared to offer their cloud-based storage infrastructure sized for the same data volumes, or considerably less than this figure. I would encourage you to speak with them to find out how much less. Next, I want to look at the concept of a proactive DICOM data migration, because it's somewhat intriguing. Let's look at 3 examples of this concept. I'm going to show you the projected cost of migrating an organization's data in years 1, 3, 5, and 7 from an incumbent PACS to a new PACS. The current market cost for DICOM data migrations, including cleansing, is roughly 21 cents a study. Now, that obviously could be 21 cents for all studies or 21 cents for radiology, something else for cardiology. The point is that I'm going to use 21 cents in the numbers. So compare those PAX-to-PAX migration costs to the cost of proactively migrating the historical data and the new data to a VNA-fronted on-site storage solution that is self-managed. To see what would that cost? A lot of numbers on the page, as usual. Let's just focus on the red. This is the same single hospital profile that I used earlier. The projected cost of their future data migrations in year 1 through 7 are shown here. Now, I've highlighted the cost of migrating the data in year 5. Let's say that's the year that the current PAX would be replaced. Now, I'm assuming the current cost of data migrations for all those future years. I can't predict how that cost is going to change, so bear with me. This is just an example to think about. I've line itemized the various costs associated with deploying the on-site VNA-fronted storage solution. These are regional averages. Note that the VNA license covers both the historical data and all of the new data going forward 5 years. So there's a discounted license fee here because it's just covering managing the data at rest. The 5-year total cost of ownership for this on-site DNA infrastructure is $1.4 million. Now, it's duly noted that this is considerably more than the $382,000 that it might cost to migrate the data from PAX to PAX in year 5. Bear with me. Here are 2 more profiles. Once again, the 5-year total cost of ownership for the proactive migration to an on-site, self-managed, DNA-funded storage solution is higher than the predicted cost of simply waiting and migrating that data from PAX to PAX in year 5. So I know you're wondering, so what's the rationale for this apparently more expensive proactive DICOM migration to a neutral storage solution? Agreed. The cost of the proactive migration strategy is apparently more expensive. But I want to point out a few following key issues. Number 1, the migration of image data from one proprietary PAX format to the next proprietary PAX format is a waste of hundreds of thousands of dollars because there's no end to this. And the cost of continuously migrating an escalating volume of data is simply unsustainable. Number 2, the data in the VNA-funded storage solution is ready for use by the next PAX. So there are no costs associated with maintaining the old PAX while the data is being migrated to the new PAX. And depending on the volume of your data and the version of that PAX, that could be a couple of years' worth of time to keep the beast alive while you get the data out of it. Number 3, the VNA storage infrastructure is effectively the long-term archive for the next PAX, and that will lower the cost of that PAX correspondingly. Number 4, GNAX is quite confident that they can significantly lower the cost of this proactive data migration strategy by managing the VNA storage infrastructure in their cloud, not on your site and not you having to manage it. For one thing, with an on-site CapEx model, you have to buy expansion storage, which could be as much as 50%. So for as much as 50% of the storage that you pay for up front is not being used. Whereas in the cloud model, you only pay for what you need as you actually use it. This is the third economics example I wanted to go through. I'm kind of interested in this one myself. I'm comparing the cost associated with image enabling the EMR with individual interfaces to 3 clinical PAX viewers. I'm going to compare that to a single interface to a univiewer. And to be fair, let's assume that the organization has already purchased the radiology and the cardiology clinical license, and they've already established those interfaces to the EMR. So these yellow highlighted costs will not be included in the totals on the bottom of this page. Furthermore, let's assume that those clinical viewers were established 2 years ago. So the blue highlight indicates that the cost of the maintenance and the administration of those interfaces is only going to be for the next 3 years. And let's assume that the third department PACS, like a endoscopy PACS, whatever, is going to be purchased this year. The far right column shows the cost associated with purchasing and interfacing the univiewer. All the costs shown in this example are fairly representative. The 5-year total cost of ownership for image enabling the EMR with individual PACS viewers in this example is $567,000. The 5-year total cost of ownership for the univiewer approach is only $324,000. That's an estimated 43% savings. Again, don't dwell so much on the numbers, dwell on the concept. If we assume that both the radiology and the cardiology PACS will soon be replaced, we have to consider the cost of those clinical licenses and interfaces, etc., in our 5-year TOC calculations, for all 5 years. So it's obvious that the cost of the 5-year total cost of ownership for image enabling the EMR with individual PACS viewers is much higher. In this example, $981,000. The 5-year TOC for the univiewer approach at $324,000 is even more attractive. The estimated savings in this example are in the 60% range. And once again, don't get hung up on the actual numbers. Just think about the concept. 3 versus 1. Got to be less expensive with 1. So perhaps the biggest and the most complicated economics consideration would be the comparison of on-site versus off-site. There are far too many variables in this example to discuss in this presentation, so let's just look at the high points. I think it's worthwhile for the organization to compare the two approaches. By that I mean a capitalized, self-managed, on-premise, dual-sided, vendor-neutral archive versus a hybrid VNA, which means that the secondary VNA subsystem is hosted in a vendor-managed cloud. Now, the issues you must consider include, 1, IT resources. Do you have that level of IT resource? 2, whether you have or want to have your own appropriately remote second data center. 3, do you have the ability to procure storage on close to an as-needed basis? And 4, do you have sufficient capital funding? I've seen some very thorough cost models suggest that the 5-year TCO for the hybrid VNA will be approximately 30% lower than the corresponding self-managed on-premise TCO. So once again, I think it's worthwhile working with a cloud vendor to compare these two models. So let's address some frequently asked questions that I come across all the time. First, will a cloud-based, vendor-neutral DR and BC solution, that'd be my level 3, affect my choice of the next PACS? Now here's a graphic to remind you what I meant by that level 3 solution. Okay? We've got our DR copy in the cloud. And we've got a univiewer there, so it's also our BC solution. All the second copy of the data is being managed in the cloud by the VNA, and it's accessible to the cloud-based univiewer. So the question again, will cloud-based vendor-neutral DRBC affect my choice of the next PACS? So the level 3 configuration will indeed affect the choice of the next PACS. First of all, current PACS vendor has much less leverage because there's no migration issue hanging over your head. Of course, the next PACS has to meet a few key criteria. 1, it has to meet a list of VNA compatibility requirements, and some current PACS, frankly, will have a problem with that. Number 2, the next PACS will not require a long-term archive and only a modest short-term cache. Require an enterprise viewer, or no more than a license for minimal access. And cutting these out of the next PACS configuration should significantly lower its cost. 3, the next PACS only has to focus on meeting the operational requirements of the imaging department. Even a level 3 configuration shifts the choice of the next PACS back to the imaging department. How does this eliminate conventional DICOM data migration to my next PACS? I get that question a lot. First of all, only the most recent 18 to 20 months of image data needs to be migrated from the VNA to the short-term storage solution of the next PACS. The department-specific VNA directory is copied to the next PACS directory, making the new PACS aware of all the historical studies from that department. These two types of data migration are much simpler, faster, and much less expensive. Does deploying a level 3 solution lock me into that vendor's VNA technology? Very good question. In my opinion, if you have chosen the right cloud vendor, the answer is no. Your data can be moved to another VNA solution without a costly migration, assuming that you've negotiated this issue in your contract. Assuming your cloud vendor is using a legitimate VNA technology, you can choose any other legitimate VNA solution for an on-site deployment. It's even easier to choose a different univiewer for the on-site deployment. At what level could the organization participate in an HIE? The fundamental requirement for participating in an HIE is adding XDSI functionality to each of the organization's departmental PACS. Alternatively, the XDSI functionality can be provided by the Level 2 cloud-based vendor-neutral data management configuration. Here's a graphic to remind you what that Level 2 solution looks like. This is basically a VNA-fronted disaster recovery solution. Bear in mind, there's no univiewer in Level 2. When the organization decides to participate in an HIE, the cloud vendor activates the optional XDSI and companion EMPI functionality for the organization's account, thereby making the second copy of the organization's data available for exchange through an HIE. There is no need to add XDSI functionality to each of the department PACS or deploy a local EMPI. The organization can also start forwarding non-DICOM and non-image data to the cloud, so it too becomes eligible for HIE exchange. It should be noted that a Level 2 configuration is the minimal requirement. The Level 3 configuration, with that univiewer, simplifies the display of the images that have been forwarded to an HIE. Since the zero or near zero server-side rendering univiewer is a relatively new generation display, it's not unusual to hear skepticism about its ability to meet performance expectations. So what level of performance is supported by the univiewer in the cloud? First of all, let's list the key assumptions. One, rendering server and VNA must be on the same LAN in the cloud. Two, the interface between the two is web services, or the rendering server is going to require a 30, 60-day cache. In this case, typical zero-client server-side rendering univiewer can deliver the first screenful of an organization's secondary images in 3 seconds over a modest internet connection, for example, commercial broadband. Most of the basic user-directed display operations will typically deliver the resulting image in under a second or two. So here are the takeaways from today's discussion. The vendor-neutral archive can solve 7 of the top 10 tax problems. The properly configured VNA is large, it's complex, and it's a capital-intensive project that will probably require multiple years and multiple budgets to fully deploy. The good news is that similar to early radiology PACS deployments, there are small VNA precursor products that solve small problems that plague many organizations. VNA precursor products and strategies that we've reviewed include replacing older PACS media with a new generation open storage solution, a proactive DICOM data migration to the cloud, deploying VNA-based DICOM routers to simplify and guarantee data exchange, deploying a univiewer to image-enable the EMR. I think we're going to slip in our last poll question. And now, I'd like to introduce Mariana Malou, who will introduce GNAX and present an overview of its product portfolio. Mariana?
Thank you, Mark Gray, for this insightful presentation. All of you have joined us in this webinar. I am Mariana Maloof, Chief Technology Officer for GNAX Health, and we happen to agree with Michael's message here. So at GNAX, we have built a system that allows you to get started with a VNA today. We strongly believe that it's important to serve all of our customers, whether they're large or small, with a solution that is easy and inexpensive to adopt and implement, but one that is also robust enough so that it can scale to meet the largest deployment requirements. At GNAX, we do a few more things. VNAs is not the only solution that we provide. And so we have created an entire healthcare ecosystem that includes everything from a data center colocation solution in our Tier 4 data center to geo-redundant storage solutions based on cloud for use cases such as archiving, backup, and disaster recovery. We've also built an enterprise-grade cloud solution which leverages industry-leading technologies from VMware applied to healthcare. And we've also offered new software solutions for EHR and HIE in a software-as-a-service model. I want to take a few minutes to talk about our solution, and it starts with our highly available and elastic storage. We call it GNAX Plus for Distributed Object-Based Elastic Storage. This is, as I said, completely redundant, highly available, and it replicates data between our facilities in Atlanta and Dallas. So you always have a minimum of 2 copies geographically dispersed. On top of GNAX DOS, we chose Accurate Technologies Universal Clinical Platform to front-end our VNA solution. And we chose them for many reasons, some of which you can see on the slide here. They are a clear market leader. They have a proven technology. We know it works, and it works well with our cloud storage infrastructure. And we believe they're a great partner. They bring a wealth of trusted knowledge and resources to us and our customers in this particular space. The next piece, we think it's a key ingredient for our VNA strategy. This is what Michael referred to as a univiewer. We think that universal viewers are a critical piece if we want to leverage VNA for things like interoperability, business continuity, and mobility. All of these things make sense. And if you put in your studies, or a portion of your studies into a VNA platform, you will want to leverage that infrastructure for as much as possible. In other words, you want to maximize your investment. A univiewer allows users to stream images directly from the VNA to any authenticated device. And I think Michael covered some of the benefits of a univiewer, so I won't spend too much time here. But just to say that this particular element can be a critical piece of the business continuity strategy for medical imaging. In addition to that, clinicians can access images on any device, such as an iPad or other tablets, for convenience and telemedicine use cases. As you realize, mobility is one of those non-reversible trends, and we wanted to make sure that we incorporate that technology into our VNA strategy for the cloud. This slide here represents an overall logical view of what our GNAX DOS VNA platform looks like. As you can see, this is really basic VNA architecture use. The deployments on the right, they're directed to archive to the VNA edge device, which holds a local copy, a local cache, rather. And by the way, this can be 90 days, 6 months, 3 years, however much you want. The device then encrypts, compresses, and sends the data into the GNAX cloud archive. And this can be accomplished in a variety of ways. As an example, we could have a private line for one of our data centers. It could be done over a secure private area network connection. So hopefully this provides a high-level overview of what we offer in our VNA solution. Before we move to the Q&A portion of this webinar, I want to take a couple of minutes to highlight what we think is a key partnership. As part of our VNA solution that is cloud-based, we have selected some key partners, and Source HIMSS is one of them. We are partnering with them to extend our VNA and archiving solutions with more services. They bring a substantial amount of experience in radiology image management and film to digital conversion. Source HIMSS has a solid track record in managing large-scale migrations and conversions in this industry, and we're partnering very closely with them to offer more services to our customers. If you think about it, a logical extension of any film to digital conversion strategy is to move on to a conversion into a VNA. So we thought it was a natural step for us to partner with Source HIMSS to be able to provide even more value back to our customers. You can see some of their highlights in this slide, and I strongly encourage you to take a look at them more closely. With that, I want to thank you for joining us for this webinar. We hope it was a good use of your time and it was informative. And I'd like to open it up for questions at this time. Anything that you may want to ask Michael Gray or myself. And once again, thank you for joining us.
Great. Thank you, Michael and Mariano, for that great presentation. Just a reminder, a full archive of this presentation will be available at a later date, along with a PDF version of the presentation. There's also going to be an exit survey appearing shortly, and we'd appreciate any feedback that you might have for us on today's presentation. We'll now move into the Q&A portion. Please be sure you've submitted all of your questions in the Q&A panel, as questions submitted in that chat area may be missed. So be sure to submit any questions that you have in the Q&A panel. So we'll go ahead and jump right into it. Our first question is, does the level 2 approach imply conversion of the various DICOMs to a standard or neutral form?
This is Mike Gray. Would you repeat the question again?
Sure. The question is, does the level 2 approach imply conversion of the various DICOMs to a standard or neutral form?
Yes, it does.
Okay, great. And Michael, another question for you. How realistic are those cost estimates that you displayed?
I knew that with an audience of this size, that question would pop up. Let me just say this. I'm exposed to lots of pricing associated with lots of projects. So I deliberately chose to use prices that represent, let's say, the 75th percentile. It's not the average, and it's not the most expensive solutions, but they represent solid solutions in my opinion. And the cost models I'm using in the presentation are intended just as guidelines to stimulate consideration of the strategy. Obviously, prices are going to vary depending on who you are and what your requirements are. I think discussing the models with one or two vendors would be worthwhile. Then you can get real numbers with real applications behind them.
Okay, very good. Thank you very much. Our next question is, would you recommend adopting a master patient index before installation of VNA or after?
Well, I hate to be wishy-washy on this, but the fact is it really depends on what you're trying to do. I don't want to get too far into the weeds here, but there are numerous examples of where an organization, especially an organization that is comprised of, let's say, multi-facilities, and some of the facilities have been recently acquired, and so they've got a huge historical database of a different medical record numbering system. There are scenarios where you want to accommodate the different organizations and different MRN. There are a few vendor-neutral archive solutions that have the ability to do what I call pseudo-NPI reconciliation of the same patient under different medical record numbering systems. It's similar to the fuzzy logic approach of it's the same name, it's the same sex, it's the same birthday. What is the probability it's the same person? Now, in the end, in other words, the net goes out, it's pretty wide, and the user ultimately has to decide that last level is this the same person. But there are ways, in short, to solve issues related to multiple medical record numbering systems without the investment in both the original setup as well as the maintenance of an MPI. It really does depend on what you're trying to do.
All right, great, thank you. Our next question is someone wants to know, how fast are sources going XDS?
How fast are sources going? I didn't get the question at first. That's a real good question, and I'm not under the impression that they're going very fast at all. Now, there are, in other words, as an embedded application, I haven't asked the question in quite a while, but I'm not aware that they're going very quickly. There are a number of, it kind of reminds me of the old days of how fast are sources going DICOM. And the ones that weren't going very quick, you ended up attaching a DICOM converter box to it. So the analogy here is essentially the same. There are a number of solutions out there that fit into a little box that basically can XDSI enable a PAC system. You wouldn't necessarily have to XDSI enable a modality, unless, of course, the modality is not attached to a PAX and you want to share it across an HIE, then you'd have to XDSI enable the source. But generally, you think about XDSI enabling a PAX system. And if that isn't a native application in either the PAX system you have or the one you're going to buy, then you can do that with an external box. I actually do not know what the relative costs of those boxes are, but it reminds me a lot of the old days of DICOM enabling a modality with an external box.
Great, thank you. Mariano, this next question is directed towards you. Is there anything in particular about security in the cloud that I should consider closely when evaluating a cloud vendor for VNA?
That's a great question, actually. If you look at the context of cloud computing in general, security is probably at the top of the list in terms of concerns for organizations, especially when we're talking about this type of data. So, naturally, you want to have an assessment of the cloud provider's capabilities around complying with HIPAA and security in general. This has multiple dimensions to it, and it doesn't just include the procedural aspects, but also a very strong architecture around how security is baked into the cloud architecture. In the case of GNAX Health, we've partnered with companies such as Intel to work on encryption capabilities right of the chipset of the servers that we utilize in our environment to ensure that we have the adequate levels of encryption, just to name one component of that security strategy. But absolutely, the cloud provider has to understand HIPAA compliance, has to understand healthcare to be able to have a productive dialogue around how to manage security. And I could make the argument, and I don't have too much time now, but I could make the argument that in some cases you can see vulnerabilities inside an organization that could potentially go away very easily by just migrating that particular portion of the IT infrastructure or the storage elements to the cloud, just by virtue of how our cloud infrastructure is built from a security standpoint.
Okay, great, thank you. And our next question is, how many vendors do you consider to be truly vendor neutral?
Obviously a loaded question. Maybe 7. And no, I'm not going to name them.
Okay, great.
Let me back onto that.
Sure.
Probably, look, this is a lot like the early days of do you have DICOM? Okay, you remember that? I mean, however far back you want to go. Let's go back 20 years when it was kind of new. You walk into a booth at RSNA. You guys got that DICOM stuff? Yeah, we got that DICOM stuff. You don't ask any more of a question than that, and that's kind of what you deserve. Okay, yes. You guys got a VNA? Oh, yeah, we got a VNA. You have to actually understand the intricacies of what you expect that thing to do. There are a number of vendors whose solutions actually do tag marking, but they do it bidirectionally. And if they do it bidirectionally, do they do it dynamically? And if they do it dynamically and bidirectionally, how many tags can they manipulate? How large is their library? How many migrations have they done? What level of experience do they have with all the variations of the rev levels of the packs out there? So you have to keep peeling the onion to get down to it. There's a lot of other issues besides tag mapping, but the point is that the ones that are, in fact, they use the word legitimate, that would be in the top tier, there's only the 6 or 7 that I can think of, because the rest of them aren't quite there yet, but let's say they're gaining ground, and there probably will be dozens in a year or so. The point is that there's not that many that have the breadth of experience right now to do all of these things that we're talking about doing. So you really have to know what you're asking for in order to really understand whether someone does or doesn't fit into that category.
Great. Thank you very much for that answer. And with that, we are just about at the top of the hour. So I'd like to thank our speakers for that great presentation today. And on behalf of HIMSS and GNAX Health, I'd like to thank all of today's participants for attending and making this web conference a huge success. This concludes our presentation. Thanks for joining us today.